We use the finite element analysis in our designs. We don't necessarily do it on every design, but we do it to decide if the part is capable of doing what we're wanting to do, and if the machine is capable. It's a lot more accurate than trying to just calculate by hand what's going to happen, so we can actually simulate what's going on in every case. We use FEA for basically all sides of the business, all the different parts. For the work holding, there's a lot of times where we'll do the FEA on squeezing the part. When our work holding devices come in and clamp the part, it'll actually crush the part a certain amount, and it always does. So we just kind of decide whether it's too much or not enough, and really kind of get a good handle on what the grip is of the part. We also do it for rotational analysis when we're taking apart in a turning type fixture, whether it be a lathe or a VTL. We'll spin the part and decide if it can handle it or not. And then on the other side, the assembly, special equipment machines, we'll do just more or less more simple beam deflections, decide whether our bases are strong enough to handle the forces that we're putting on them during the process. We had a work holding fixture that was a large part that it was in a turning application, and the part itself weighed about 1,000 pounds, and our fixture was another 1,000 pounds. And in all of this rotation, the centrifugal forces were causing the part to go out around, and we were able to prove that our fixture was actually capable of holding the part correctly, but the part itself was so heavy and so out of balance that it was deflecting it just by itself. So we were able to go in with the FEA, look at it in detail, and decide where we needed to add supports or whatever to change and help this part hold itself up better during the machining process. And also we were able to spin the part theoretically at multiple RPMs and decide that at the obvious, I guess, at higher RPM the part's going to deflect more at lower. So we were able to tell the customer that if you turn this part at this very specific RPM, you should see this much deflection, and we can kind of pick a range there of what is the best scenario for that. We get a lot of comments that kind of let us know that our competitors are not using the FEA near as much as we are, if at all. The customer would benefit by knowing that the part is going to work, knowing that our machine is going to do what we say it's going to do, rather than just kind of taking a guess and building it and not really knowing until it's all said and done. So it's really more of an insurance, I guess, to the customer that says, hey, yeah, this is what's going to happen. We know this.